Hello all, today in this video I am going to provide details regarding Adaboost machine learning classification algorithm. This is a continuation of the previous video only. In previous video we have made some other machine learning algorithms which is providing some better results, and we have made a comparison. In this work we are going to work with the Adaboost machine learning algorithm. I am going to make a comparison that which machine learning algorithm is going to provide better results. For that, initially we are importing the libraries which we are needed, and the data set we are loading. This data set we downloaded from Kaggle. You can just give us email spam detection data set. Kaggle means in that case you will get this data set. This data set is having nearly 3 entries, which is an unnamed one. Next is email text and next is email type. Then we are getting the info of the data set. From that we are getting to know that the unnamed one is integer and other two are object type. Then we are checking whether our data set is having any null values. You may notice that within the email text we are having an null values of 16, so we have to drop it. And also the unnamed entry, it's just a serial number, so we no need. So we are going to drop the unnamed entry, and also we are going to omit the entries which are having null values within the email text. For that we are using the drop now function and drop duplicate functions, and again we are just checking with the missing values. And in this case you may notice that the unnamed variable is also omitted, also it is not having any missing values. Then we are getting the data. Our data shape is nearly 17,538. Then we are making a plot with the email type column to just check that how many safe email and phishing email is having. And when compared to this uh, safe email, phishing email count is very less only. Then we are moving to the determination of x variable and y variable. The x variable we are calling the email text, and within the y variable we are calling the email type. Then we are using this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And by the use of the train test split function, we are determining variables like x train, x test, y train and y test. Then already we noticed that our data is object type. We have to convert it into vectors. For that we are using the vectorizer. The vectorizer used in this work is tfidf vectorizer. This vectorizer we are applying to the variables like x train and x test. This variables only we will be using in the further model training and evaluation. So previously we have worked with the logistic regression, and we have displayed the prediction, confusion matrix and the classification report, and has got 96% accuracy. Then we worked with support vector mission and displayed the predictions, confusion matrix and displayed the classification report having 97% accuracy. Then we worked with the catboost classifier and displayed the predictions, confusion matrix and classification report, and we noticed that we have nearly 97% accuracy. Then we worked with passive aggressive classifier and displayed the predictions, confusion matrix and classification report, and has got nearly 96% accuracy. Then we worked with the random forest and displayed the predictions, confusion matrix and classification report, and has got nearly 97% accuracy. Then we worked with the naive Bayes and displayed, that is multinomial naive Bayes, and displayed the array, that is predictions, then confusion matrix and the classification report, and we have got an accuracy of 94%. Then we worked with the KNN and we have displayed the predictions, confusion matrix, and have got 87% accuracy with the classification report. Then we worked with the decision tree and we have displayed the predictions, then displayed the confusion matrix and also the classification report, and has got 90% accuracy. Then we worked with gradient boost and displayed the predictions and the confusion matrix, and has got 93% accuracy. In this work, we are going to work with Adaboost classifier. For that, initially we are importing the libraries which we are needed, and then we are declaring that library within a function. That function we are using for training and testing. Training is done by use of the fit function, and testing is done by use of the predict function. In training we are using the training variables, and in testing we are using the testing variables and making a prediction. That prediction variable we are making to display within an array. Then we have plot the confusion matrix and the classification report. The confusion matrix is plotted with the test values only, and in the confusion matrix, if you notice, means we have very less number of values. This is due to the test. Within test variable we are using only 20% of data, and remaining 80 is taken by training. So only we are getting this less number of values within the confusion matrix. Then we are displaying the classification report and has got an accuracy of 92%. So some values it may change. Why? Because we are running so many times. No, at that time each time it is showing different accuracy. So only it is varying. 98 means in the first time we are running SVM, it is showing 98. I think now it has changed. So the we have made the values which we are getting in the first time only. Among that you may notice that SVM is getting the highest accuracy, and this KNN is having the least accuracy. Adaboost is 93, which is not as much low and not high also. So based on this, we have made a bar plot. So this is the bar plot description. You may notice that which algorithm is providing better results and which is providing some lower results. So this is the comparison. So in the next work, we will be working with XGBoost classifier and will make a comparison regarding it. Thank you.